Today we're going to spend some time looking at basic trigonometric, such a fun word to say, trigonometric identities. So our goal is that we're going to know and use basic theorems relating to the value of sine and cosine functions. So our first thing by way of introduction is just to remember where we derived this idea of cosine and sine, the definitions. Remember that the cosine is simply the x coordinate of the point on the unit circle, and the sine is just the y coordinate of that. So if you know the cosine of theta, then you can easily find the cosine of the opposite of theta. We could also find the sine of theta, and we can find much more, because everything is so interconnected that once we know one piece, all we have to do is play around a little bit to find the other stuff. Okay, so we can do so by using what's called trigonometric identities, which are equations that are true for all values of variables for which the expressions on each side are defined, as opposed to undefined, divide by 0. So if we recall, no matter where we place our theta, and we're going to focus right here just on the quadrant 1 to see where things derive from. Remember that when I have some theta that goes to here, then again, I have an x and a y point. And we already know that if this is my x, then this part right here represents the cosine. This distance is the cosine of theta. And the other component, this distance right here, represents the sine of theta. So looking at it as the triangle in a triangle. So if this here is my theta, then this length right here is the cosine of theta because it represents the x coordinate of that point that's over there. And then this one has to be the sine of theta. So now we have lengths. Instead of simply just a variable, we now have an actual number. Once we know what theta is, then I know how long this is, and I know how long this is. Of course, the Pythagorean Theorem says a squared plus b squared is equal to c squared, which means, in this case, the cosine of theta squared plus the sine of theta squared is equal to what? How long is this right here?
1.
It's the tangent, but since it's my unit circle, it's a 1. So notice what we just found out. And the way that we write it, instead of getting confusing with the parentheses and the square, we just like to put the square next to the cosine, but it means the same thing. The square of theta, cosine of theta squared, is another way of saying is cosine square theta. So those are equivalent statements. So notice it's simply a squared plus b squared equals c squared, and c squared is 1. So this is called the Pythagorean Identity Theorem. Okay, so let's look at page 2 and look at an example. If the cosine of theta is 3 over 5, or 3/5, what's going to be the sine of theta? Well, we're going to start off with the Pythagorean identity. Now, you don't have to write this every time. Just for now, I'm writing it just so that you see what's happening. I already know what the cosine of theta is. It's 3/5, so all I'm going to do is substitute it in there. So notice the 3/5 has to be squared, plus the sine squared of theta is 1. Just to simplify here, this part here becomes 9 over 25, plus the sine squared of theta is 1. Now I'm going to subtract from both sides to get 16 over 25. 1 minus 9 over 25. And of course, when we take the square root, looking back to your Algebra 2 days, beep, 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 don't forget that you have a plus or a minus. Don't forget you have a plus or minus mathematically. So, carrying this over, the sine of theta is equal to plus or minus 4/5. So check your answer here for example 2. And tomorrow we're going to walk through other theorems besides the Pythagorean identity.